Now, let us look at chapter 4.2, which is the differential of our inverse trigonometry function. Okay, as you already know, that is, I did mention in one of the video that is, okay, this one basically are the added part of your vocabulary. Okay, so now let us look at the first set of a vocabulary, that is differentiation versus our integration for the special case. Okay, what is the meaning of this special case? That is, we have the sine inverse of x. Okay, not like the second one over here. We have the sine inverse of a w, where our w is a function of x. Okay, so this is only an x. Okay, so now when you differentiate sine inverse, you're going to have 1 over square root of 1 minus x squared. And where our x must, the absolute of x must less than 1. Why? Because that is, if you look at this formula, over here is a 1 minus x squared, and it must be sit inside our square root. If your x squared is larger than 1, then your square root will become a negative value, which is not valid. Okay, so if you look at our sine inverse, differentiate sine inverse and cos inverse, there is a huge difference. Not say huge difference, the difference is only one is with a positive sign, another one with a negative sign. Okay, so contrarily, that is, if you look at our integration, okay, so when you try to integrate, okay, when you try to integrate negative, okay, let's say negative 1 over sine 1 minus x squared dx, you can either say that this is a negative sign x plus c, or you can say it as an cos x plus c. Both are correct, because the difference between these two is only the sign, positive and negative. While for our tangent and our cotangent, okay, inverse, both also have the same value, except the opposite sign, which our tangent is a positive, our cotangent is negative, and our secant is with the positive, and our cosecant is negative. And if you remember, if please pay a little bit attention over here, that is our absolute x. Okay, the x must put let it to sit inside an absolute. Maybe sometime you see in certain books they didn't put an absolute, but keep an habit just writing the absolute over here. Okay, so because of sine cos sharing the same value, the only difference will be only the sign. So this is only one formula, this is the second, this is the third formula. So for the integration, basically you only need three different formula. The first one is integrate of 1 plus x squared. The second one will be integrate 1 over absolute square minus 1. And then the third one will be the 1 over square root 1 minus x squared dx. Okay, and if you feel that you want to use the negative cos, also can. If you want to use the negative cotangent, also can. Or if you want to use the negative cosecant, also can. Okay, now if you have the general case, okay, so means that you want to differentiate sine inverse w. Okay, so what is this mean? Okay, our w is a function of x, or we can say that we use our substitution or our chain rule to differentiate. Okay, so one of the example will be, let's say you want to differentiate sine inverse 3x. Okay, although it is different, maybe you say that differentiate sine inverse x and differentiate sine inverse 3x are similar. Yeah, it's similar, but the thing is you have a coefficient of 3. So means that one way that you can use the chain rule, or you can use this, you try to replace this, actually is by using the chain rule. Okay, so now then for this one is the general formula. which our now is not x itself, so we have a w. So actually the formula will be also the same. The only thing that is, remember in our channel, when you follow exactly the original formula, and don't forget to multiply with the differentiate of the substitution you already substitute. Okay, so but the thing is, when you return back to the integration, okay, if you return back into integration, it is not that alike anymore. Now, if you see over here, the formula provided to you is integrate 1 over square root a square minus x square dx equals to sine inverse x over a. And you need to remember only the you need to pay extra attention for the tangent. This is 1 over a, and our secant also 1 over a. The only one person is without 1 over a is sine inverse. Okay, now then one more thing that is you have to remember, there are certain book they provided you another one, another version of this formula. They're going to give you integrate 1 over square root 1 minus u square dx equals to sine inverse x over, okay, u, okay, u plus c. Okay, so then you need to be a little bit careful with this formula, okay, but because this formula is following whatever in your module, so we can't carry on using this one. Okay, so now let us look at what is the difference between our differentiation for the special case versus our general case. Okay, so for the special case, if you see that there is only difference is over here, there is no dw over dx. Okay, so if you see that is, if you want to differentiate sine inverse x, this is sine inverse w, which is a function of x. So exactly the same, the x you replace by w square, and but you have a dw over dx. The rest of it are the same. And then for integration, okay, so integration, remember this is a square, this is 1, okay, so that's why you're going to have x over 1, so this is our special case. So this is x over 1 also is our special case, okay. So now if you want to use this formula, so later on we can discuss that is how you try to make your question look like this integration, so you can directly to use this formula. Okay, so this one, okay, so the difference is only this is 1, this is a, so you have x over a. So like tangent, okay, this is 1, that's why you don't have x over 1, so you have x over a, 1 over a. So now let us look at our first differentiation, differentiate sine inverse 3x. Okay, so if you want to differentiate sine inverse 3x, okay, so easy, we use this formula, this is w, so our w is 3x. So directly use that 1 over square root 1 minus our w is 3x, so just put 3x inside square dw dx, so your w actually is 3x, so dw dx equals to 3, so you just put 3 here. So if you want to tidy up also can, you can write as 3 square root of 1 minus 9x squared, so settled. Okay, so how about this one? Same thing, our w is x squared, so we need dw dx actually is 2x. So now follow exactly the formula. So we have negative 1 over square root 1 minus our w is x square, and then dw is 2x. So if you want to simplify negative 2x square root 1 minus x power of 4. So settled. Okay, please don't try to simplify whatever denominator and nominator because it is inside a set. Okay, then this one is a little bit lengthy, but the thing is still the same. Our w is 1 over 1 plus x squared. Okay, if you want to easier to differentiate, just bring our 1 plus x squared to become up the power -1. So then dw dx will become -1. Push the negative in front. 1 plus x squared. -1 minus 1 is -2. Don't forget to use the chain rule. Differentiate inside is 2x. So now this question will become 1 over, our w is 1 over 1 plus x squared square. What is our dw is 2x minus, okay, 1 plus x square squared. Why there is a no negative? Because I bring it down again. Okay, because as I said many times, we not allowed to have a 3-layer thing like that. So please simplify it. So simplify this one first. So 1 over 1 plus x square plus 1 over 1 plus x square multiply -2x, 1 plus x square. Okay, so this one will flip to up. So you're going to have 1 plus x square over 1 plus x square plus 1 multiply -2x, 1 plus x square. This can simplify. So your final answer is -2x. 1 plus x square. If you want to expand it also can. If you don't want, just leave it as it is. Okay. So how about this one? So now our w will become exponent -x. dw dx, differentiate exponent, always get back exponent. And don't forget the power of it is -x. So you're going to have a negative e, so on. So then write back the formula 1 plus e -x square. Then our dw dx is negative e minus x. Okay, so negative is positive. So I have a e minus x at top. 1 plus e minus 2x settled. Okay, if you don't want to change it to become -2x also can. You can leave it as e minus x power of 2. The only thing that if you sometimes compare with the actual answer, you will cannot get exactly the same. Okay, so how about our second? Okay, identify what is your w. Your w is this one. So our w is x squared minus 1 half. Okay, so dw dx is become half x squared minus 1 minus half, and chain rule of x squared is 2x. So these two simplify. So you have an x over square root x squared minus 1. Okay, so write back into the formula. Follow exactly. So set x squared minus 1, then square root x squared minus 1 square minus 1, then multiply with x over square root x squared minus 1. Okay, now this one, because of a set and square, so we cancel off. So and then these two are same. Okay, so you're going to have an x, then x squared minus 1. Then we have a large square root. Okay, these two is already cancelled. We have an x squared minus 1 minus 1. So you have, finally, you have x over x squared minus 1 multiply of us x squared minus 2. Okay, that's all. Okay, then how about our cosecant? Over here, identify our w actually is ln x. So w actually is ln x. So dw dx actually is 1 over x. So copy back negative 1 over. Don't mix up. This one is w, so it's an ln x. It's absolute minus ln x power of 2 minus 1, then multiply with 1 over x. Okay, so if you can keep it in this way also can, because not much to be simplified. Okay.